Hello, ladies and gentlemen, my name is Kurt, and welcome back to Space Engine. For those of you who missed my video last year on Space Engine, this is a 3D space simulation software, a lot in the same vein as Celestia, for those of you who are familiar with Celestia. This right now, since I've made that last video, has been updated, a few updates. We're up to 0.95, still in beta, but it's an amazing piece of software I recommend everybody check out, and you can do so over at spaceengine.org. But I'm here today, just outside the orbit of the moon, a few 100,000 kilometers away from Earth. Let's actually zoom in a little bit closer to the Earth, right past the moon. So long. And hello there. Oh, inside the planet. Oh, there's the ocean. Okay, let's back out, a little bit faster. Okay. Accidentally plunged off of the coast of Costa Rica there or something. Guatemala? I don't know, one of those. But yeah, here we are in Space Engine, and the reason I'm back here is because I had quite a few questions in my last Stellarium video where I was talking about the conjunction between Venus and Jupiter, and also there's some interesting up-to-date astronomy news going on. There's been a supernova discovered in M95 galaxy, so we're going to go take a look at, in reference to the Milky Way galaxy, where M95 is, and then I'd like to touch on a few cool new features, or features I've just learned about with Space Engine. But first, let's talk about things a little bit closer to home here in the solar system. I have it currently running at current time, so this is March 25th. We're looking at 3:15 p.m. Central Daylight Time. Obviously, there I am off the Lake Michigan there. Forgot the name of it. Lake Michigan there off of in Chicago. So there I'm located. So it's getting on into the evening. But if we spin ourselves around here, we can take a look. When it does get into evening, after the sun sets, we're going to see Venus and Jupiter in the night sky, in the western sky. And for those of you who've been paying attention, that pretty much has been the view the last few weeks. Venus was closer, but now it's pulling away from Jupiter there. And what I wanted to address was a lot of the questions I was getting were, Venus is obviously closer to the sun than us, but Jupiter is way further out. How is it that Venus and Jupiter are so close in the sky, and why is Venus, despite being much smaller than Jupiter, why is it brighter in the sky? Well, first of all, that just has to do with distance, why Venus is brighter. Venus is also very reflective because it just has entire surface covered in clouds, so those clouds reflect a lot of the light. There's, the runaway greenhouse effect going on Venus. But if I pull back, I can illustrate what I'm talking about in terms of the distance. Oh, hello, sun. You're rather bright this morning in space. So yeah, let me pull out, and I'm actually going to get way outside of the solar system. Oh, hello, green effect. Let me turn off. Oh, that's not it. I'm going to turn off the lens flare effect. That's a little bit overabundant. Lens flares. Nope, that's not what I want. Diffraction spikes. There we go. Okay. We'll do with the Michael Bay effects, the lens flares, and the bright sun when we're doing more artistic things. But I've pulled way outside of the solar system here, and if I turn on the orbits, which are right here, this is the orbital plane. Obviously, from our vantage point on Earth, things look very flat and symmetrical like this, so that is why Venus and Jupiter appear so close in the night sky. But if I bring us out into the third dimension, you can see that Jupiter is actually on the opposite side of the sun, and Venus is actually getting closer to us and going to overtake us in its turn around the sun. So it's pretty advanced concept, actually, and don't feel bad if you didn't get it right off the bat, because it took the humans a couple 100,000 years to figure it out, and even then it was less than 500 years ago that Copernicus figured out the heliocentric model and actually put it down on paper with math to explain the orbits of the planets, to explain how they move through the sky. So yeah, it seems simple once you realize the geometry at work, but just the distances and the speeds and the sizes of the different planets are just still too much for any human brain to comprehend. But I hope that kind of resolves some questions in terms of that. So yeah, just to illustrate again, when I come back down into the plane of the solar system and get a little bit closer to Earth. Ooh, not too close though, I don't want to Oh, right past it. There we go. This is pretty much our vantage point from Earth. You see Venus and Jupiter close together. So that's a really cool way, and that's what I was talking about when I was in Stellarium, where you see these conjunctions of planets. You can kind of, in your mind, draw the imaginary lines that make up the orbital planes of all the planets and kind of put Earth in the middle of that, and it's kind of a cool little thought experiment you can do. Another thing I can do here, let me make everybody sick by rotating, is I can speed up time. Oh, that's slowing down time. Yeah, I can speed up time, and as I mentioned, on June 5th, we're going to have a once-in-a-lifetime event. Venus is going to pass between the Sun and the Earth, and like I said, because Venus is on the inside track, much like if you're running on the inside track of a track and field track, you're going to pass somebody who's on the outside track running at the same speed. So, as you can see, Venus catches up, and then right about... that's June 2nd, June 5th. Venus is in perfect alignment between the Sun and the Earth. And this happens so rarely because if I come back down, get everybody sick again, if I come back down into the plane, you can see that all of the planets don't necessarily orbit at the same angle. So it has to be a perfect set of circumstances in order for Venus not only to be on the same plane, but to be within the small radius that could cover up the Sun. So that's what's going to happen on June 5th, is Venus is going to come in front of the Sun. I don't know if I could line this up properly. I can turn off the orbits. Yeah, this isn't quite the software to do this in. Objects, orbits. Yeah, Venus is in front of the Sun, just take my word for it. But yeah, that's something cool you can do with this type of software. Let me go back to current time, just so I don't get completely lost. Current time. Alright, and just for the fun of it, let me turn back on crazy lens flare effects. And this is something that, like, Celestia doesn't have, are these kind of neat special effects and the blurring of the background stars and things like that. So that's kind of a reason I like this software a little bit more, just because it's very beautiful to look at. But now, I'd like to get a little bit closer to Earth. Oh, past Earth, slow down. It's a little bit hard to navigate through space. There, stop going through the planet. Come on, let's go back out. Alright, we've extracted ourselves from the planet, but if I turn around and look for Mars, where are you? There's Mars. I'm going to do a search for, I think that's F3. I'm going to look for the supernova that was just discovered on March 16th. That is in galaxy M95, better known as NGC 3351 in this software. I'm going to select it, and from here you can see it's actually conveniently apparent to our location in the sky, just a few degrees, actually I think less than a degree away from Mars. So it's a pretty tempting object to go see for amateur astronomers, because you just look within a half a degree of Mars. There is a slight problem with that, in that the brightness of Mars actually washes out the galaxy and makes it hard to see. But regardless, we don't have to worry about that, because we're going to travel to M95, some 38 million light years away, so buckle your seatbelts, warp speed. Whoa, look at all those galaxies. Holy crap. I should probably turn off those labels, but yeah, all those individual dots are individual galaxies, not stars, so that's something really cool. Let me, like I said... Let me turn off the galaxies. So there we go. Yeah, so here is Space Engine's graphical representation of M95. It's a barred spiral galaxy, which is very similar to the Milky Way. In fact, this one, I believe, is 75,000 light years from end to end. So from... I'm trying to select stuff. I know you can't see my cursor for whatever reason, but yeah, from end to end, it's 75,000 light years across. The Milky Way, I believe, is 100,000. So if you're looking for an analog to the Milky Way, this is a pretty good galaxy to look at. But actually, pretty much right where my cursor selection is located is where they found the supernova on March 16th. Of course, the supernova actually happened 38 million years ago, because that's how long the light has traveled to get to Earth. Wrap your mind around that. But yeah, the supernova is cool because it's a Type 2 supernova. They discovered it's from a star that was about 9 times the mass of the Sun, and they were actually able to go back this past week and look at archive data of this galaxy taken from Hubble and other telescopes, and they were able to find and track down the specific star that has now blown up and turned into a supernova. So that gives them scientists a really good idea and a way to analyze the star before and then after the supernova. It's something that only has happened a few times before we've been able to identify that. And that's because M95 on the galactic scale is pretty close to the Milky Way galaxy. But the interesting things... Oh, no. We'll come back here, M95. The interesting thing about supernovae is that they're the death of a giant star, and what happens is all that heat and all that pressure ends up taking the basic hydrogen and helium, the basic elements of a star, like our star, and it ends up going back and fusing elements together and creating new elements like calcium, iron, sodium, oxygen, and carbon, which get blasted out into these star-forming regions in the outside of these spiral arms of this galaxy. And then those elements go into making new stars and potentially new planets. And if one of those planets were to happen to get a little smidgen of that oxygen and carbon that was just created, I don't know, it could turn out to have some sort of life form that depends on oxygen and carbon, much like ourselves. So it's really cool, and that's something you can trace back to even our own solar system. You know, the iron in your blood is the same iron that's in the core of the Earth and other places in the Milky Way, because it all came from the same supernova, or series of supernovas. It was fused in those, stellar furnaces, I guess you could call. I'm getting a little tongue-twisted. This just kind of blows my mind. It's one of those things, Carl Sagan says, we are made of star stuff. Well, it's true. And we're watching it here on M95 happen for real. So yeah, that's totally and completely mind-boggling and amazing. But yeah, those are the two things astronomically that we're looking at in Space Engine that's going on. But I'd like to head back to the Milky Way. Let's go back to let's go to Saturn just for the heck of it. We've seen Earth. We see it every day. So let's. All right. Here's what the Milky Way looks like from M95. Basically nothing. You have to look among all these dots. All these dots are individual galaxies, not stars. So let's go get back to a little bit more familiar ground. It's Saturn. Slowly picking up speed. Here we go. Traveling through space and time in our spacecraft of the imagination. There is the barred spiral of the Milky Way galaxy, and we're somewhere on the outside in the Sagittarius arm. Whoop. And here is wonderful Saturn and its many, many moons. But yeah, this one of the new features that they had before in Space Engine, but I'd like to kind of check out and play with, is basically they have, when you go out and explore certain areas of the universe that haven't quite been charted yet by mankind, Space Engine procedurally generates different nebulas and stars and even solar systems and planets, because it's actually something. In the last couple of months there was a paper released where it's been found through a whole bunch of research that it's actually quite common for a star to form with planets around it. It would actually be uncommon for a star to not have planets. So it's something really interesting, and only within the last 10-20 years have we discovered that there's so many more solar systems other than our own out there. It's really an exciting, in the next 20-50 years, a lot of interesting science is going to come out of this if we can put it in the budgets for science. We can find out a lot about our place in the universe. But I would like to check out this procedurally generated universe that Space Engine has created for us, and I'm just going to let's find someplace interesting. Let's see. I'm not all that familiar with the constellations as they appear from Saturn, although they shouldn't appear all that differently as they would from Earth. I'm looking for Orion. Where are you, Orion? Because I want to see because obviously the Orion Nebula is a place that has a lot of star-forming regions, and they've actually detected through Hubble telescope pictures that there's quite a few protoplanetary disk in Orion. God, I can't find it. I have to go back to Earth. There it is. All right, the Orion's belt is what I have selected there, and here's the Orion Nebula. So let's check out the Orion Nebula, and then I'm just going to at random pick a star within the Orion Nebula, and most times this software will automatically generate a planetary system around that star. But as you can see, the constellation Orion kind of falls apart once you're inside of it. Got some sort of pulsar going on there. I don't know if that's a software issue. But let's choose that star. This actually might be further away than I want it to be. That star, a white main sequence star, much like our own sun. So let's zoom into here. This says it's a triple. It might be a triple star system. We're gonna get a little bit closer and potentially. Oh, hello. Color problem. We're gonna go through the Orion Nebula. We're gonna check out this system. Cross your fingers for planets. I think those little numbers outside there are planets. Let's turn on orbits. Yep, we found some planets. Let's check out what the furthest one looks like. This one is a frozen gas giant. So yeah, even though in real life nothing says that these two stars have planets around them, Space Engine has just taken the data, the random data that perhaps this percentage of stars actually do have planets, and of those, the planets are, ooh, it's like a Saturn. Of those, these planets are gas giants, are rocky, Earth-like planets, but, ooh, this is a nifty little planet. Look, everyone, we've discovered a planet. But yeah, here we are. Where's the, ooh, that would be quite the sight in the night sky. It gives little, in the upper left-hand corner, it gives little descriptions of what the characteristics of the moon or planet you're looking at. All these appear to be frozen ice worlds because we're so far away from the planetary, the star in the center of this system. But yeah, this is just, I've been caught doing this, for many hours, just getting lost, randomly clicking on things, different stars to see what I can find. Ooh, very interesting. It's a very reddish hue, perhaps it's rich in iron, much like Mars is. A lot of oxidation going on there. That's cool. So let's check out one of these other planets that are closer to the star. What do we got here? Cold gas giant. What does this one look like? Cold ice giant. Okay, well, I'm assuming because this is a triple star system, it would be very difficult for many planets to get too close. That would be one hell of a sunset, to be honest. 3 stars, 3 suns going down. What do we got? What do we got? Very Jupiter-like. Looks like a caramel sundae or something. The caramel sundae planet. Cold. Yeah, all these places are pretty cold. So yeah, this is a really nifty part of nifty. What is this? 1940? It's a really cool part of the this software. Cold desert. So I think before we leave here, I think I'll have to take a look at another planetary system just to see if we can find something. Maybe we can find something that's habitable to life. Ooh, this one has polar caps. Desert for sure. These dark features we're not sure about. Yeah, you could start to like imagine doing science on each of these little planetary systems. It does have an atmosphere, so that's interesting. I actually want to leave the galaxy here. So long, binary system. There goes the Orion Nebula, and here we go outside of the Milky Way. This is just an estimation of what the Milky Way looks like. Obviously, we don't know what it looks like for sure because we can't take a picture from it from the inside, so it's a pretty good guess based on data that we have. But let's check out the Large Magellanic Cloud, which those of you in the southern hemisphere, Australia, if any of you are watching from Antarctica, these are frequent items in your night sky. Frequent objects, items. So let's see. And even within here, we can probably Zoom in a little bit and then see if we can find any sort of star systems, and then see what the night sky would look like from within here. Okay, here we go, inside the cloud. Let's choose that. A red giant. I don't think planets form very frequently around red giants. Yellow dwarfs. That looks promising. Let's check out this yellow dwarf. Here we are, and excellent. Oh, this one's got a whole... Put on your sunglasses. This one's got a whole crap load of planets. Wow. What do we got here? A warm ice giant. That's a little bit of a contradiction. Warm ice giant. Warm Oceania. Ooh. Let's check this out. Amazing. It's in the upper left, if you look under mass, that is 0.24 the mass of Earth is what that's saying. So it's a low mass, low density planet here, but it's an Oceania. Is it a water world? Oh, it's covered in clouds. That's pretty freaking awesome. Oh, got the brightness. It had some moons too. Perhaps some of its moons are habitable. Khalid? I don't know what that means. I'm gonna try to find... Yeah, so, if you happen to be visiting this little moon out here and you looked back to see what the Milky Way looks like, that would be some pretty interesting night skies to have a giant barred spiral galaxy in your field of view. It would actually be a little bit distracting from the rest of the sky. But yeah, that's cool. A little moon we got there. It looked a lot like the other moon that they had. Let's just do a quick survey of these planets. Perhaps there's life somewhere. Oh, I want to select that one. Another Oceania, very interesting. I could be doing this all day. I'm not going to. I'm going to check out this cool ice giant. I'm sure it's got some moons that might be interesting. And then I'm going to call this video a day. Ooh, this is very, very Jupiter-like. Very cool. Interesting. What do we got orbiting here? More cool Salinas. I think that's Selena is one of the minor planets in the solar system, so I think that's a star. I think they're basing the nomenclature after what we already know, because obviously, and like I said before, the software is just inventing this stuff here. It doesn't mean that there's this amazing planetary system around this star in the Magellanic Cloud. It's far too far away for anybody to really look at with any telescopes. But yeah, this is pretty cool. Maybe I'll come back to this software every now and again if there's an update or if there's something else cool happening in the world of astronomy. But I hope I was able to shed some light on the whole Jupiter-Venus conjunction thing and show you guys around M95 where the supernova is going on. But I think it's time to head back home. Oop, wrong button. There we go. Let's choose Earth. There we go. This is what Earth would look like from this planetary system. They would have no idea that we exist, basically. They would just have to randomly pick the star as I just randomly picked this star. But yeah, let's head back to some familiar grounds. And once again, I'm going to thank you guys for watching this video. You can continue asking questions in the comments below, and I hope to do a good job of answering them. And yeah, please leave a little like, a thumbs up if you like this video, and subscribe if you're not already, and you'll see more things like this, and obviously all my other astronomy-related software things, and also video game Let's Plays. So, as always, my name is Kurt. Thanks for watching. I will see you next time.